So thanks. I will make sure my screen recording goes, and I will hopefully get my picture up here as well. Yes, it's working. Okay. So while still people coming in, how many of you were here in July when I did the first part of this talk? So about maybe half, maybe less. So okay. YouTube has this video. If you search for DEVCLUB and Erik Jõgi or something like that, so you will find this is the recording of the initial series. So I will mostly try to continue from where or what remained untouched last time, but there is probably some overlap, and there is probably a few other things that it will be like duplicates. But anyway, so if you wish, this recording is, as I understand, I looked through it, it's quite good in terms of quality, so it's easy to follow up. There isn't like it isn't a sequel in that sense that you can still listen today. You don't have to hear the first part. So yeah, we are Codeborn. So welcome to Codeborn, everyone. So this is our offices. This space you are in right now is, we initially created this space especially for this kind of seminar room where we can have, we have our weekly something similar to DevClub internal events here and other stuff here as well. We are temporarily using that also as a workspace, so you have some of those desks at the wall here. We move them out, but ideally this is our workspace. There is, two toilets in here. There is a kitchen in the other hand where we have the break. So downstairs from the kitchen, there are two more toilets there. We have our most of our office space on the floor below us. So during the break, we can have a look there. We can do a tour. There isn't like a big thing to look at, but still, if you're interested, then we can take a look. Yeah, there will be pizza and some soft drinks during the break. I hope the pizzas will arrive. It's agreed that date. Let's see how it goes. I have still, it's the same slides I had last time. I didn't add anything, but there were two, I will quickly jump two main areas which at least I myself think I didn't go into deep enough, which is mostly about the daily practices of developers actually, not about how the eXtreme programming goes regarding like customer communication and iteration meetings, but actually which concerns daily coding. So my idea was to concentrate on mostly daily coding, like pair programming and also test-driven development. But what I wanted to ask is that for those of you who are here, is there anything else you wish I could touch more on that, because I can be quite flexible in that sense here, is that if you wish to kind of shout out, or I will leave also questions or room for questions in the end, but I know, is there anything else that I might have missed or overlooked? Not right now, probably.
Maybe design documents, is that a thing?
Okay. Not maybe answering directly, but yes, I will touch, and then if I kind of miss the answer, then poke me further in the end as well. And I will be around during the break and afterwards as well, so you can ask questions then as well. So yeah, let's get going. Sorry, no outside shoes here. Sorry about the bad lighting in the corridor. For some reason, when the weather got darker, the lamp stopped working. So yeah, luckily at least only in the corridor. Anyway, so we are doing extreme programming, which is a lot about answering the questions, what should a developer do in their daily work in order to be effective, and effective in delivering good software for the customers, whoever the customer might be it someone in-house, so if you're working for a, I don't know, a product company or just some big company, or be it some actual customers who is ordering stuff from you, it really doesn't matter. It's about the practices that a developer should do every day in order to achieve good quality code and results. So yeah, so for those of you who weren't here in July, it's I may be jumping over some things, but let's see how it goes. Hopefully it will still be a wholesome thing. So regarding daily coding, the pair programming is something that is probably which sets extreme programming and us apart from many other companies, even if the other practices are carried out in one way or the other. Then pair programming probably is quite a special thing. I would say this is definitely one important aspect which makes us successful and which makes our developers successful. And how it actually works, pair programming, is that actually we initially thought we will move those tables completely away, but then I thought this is actually a good have like an example here. This is a average pair programming workstation up here. So we have 2 screens, 2 keyboards, 2 mice, but this small thing is just 1 computer here. So this is a very typical setup. There is ample space in terms of sitting. So there are 2 chairs here, and the screens, if turned on, are mirrored in a sense that they are showing the same picture. So this is how it works in practice. The way it is that we have, these are not personal workstations in that sense. They are not set up with most of the time with not you logged in with your personal account, having your favorite cat or child or wife or whatever pictures in the background and stuff like that. These are workstations in the best sense of the word. We have team-specific accounts here which everyone knows the access to, so the people who work on that project will log in there and will share the stuff, will have their work there. The code, everything is there. Usually and we try to set up most of our environments so that it is familiar to all of the team, and whoever is joining the team is really quickly gets up to the speed. And this is not about having this is maybe a little bit about going to this collective code ownership as well. This is that whatever we build, everyone is in there, everyone is equal, and there isn't like my code style or your code style. There is this project has a code style, and everyone who is on that project, a code style in a more as broad sense as you wish, both about like having small things like line breaks, commas and curly braces and whatever, but also about the way we structure our code, but also in a way how we do our daily practices. This is about having a uniform way of doing it. It varies a little bit between different teams. Each team settles into their own kind of rhythm, and then there are some variations. Sometimes the customers, since Codeborn build software for different customers, and some are big corporations who have their own strict standards about code or many various other things. So there are variations between projects, but the main thing is that the whole team follows that and basically uses that. There isn't room for let's say personal or soloing in this work. And the way it is that whenever a pair works on some task, so most of our projects, they don't have like tens of people working on one project. Many projects are just one pair projects, so there are only 2 people working on it. A few are like 2 or 3 pair projects. I think we have one project which has 5 pairs right now. But this is on the extreme. I think the largest we have is 6 pairs, so 12 people working on one project. And then it was split into like 2 sub-projects. So even though it was the same code base, one half of it was going on one, let's say, project functionality-wise, and the other half on another one. So it's never huge teams. The way it goes is that whenever a pair takes a story that is a functionality that they will build, they will work on it together. They will use as much as, so jumping ahead, test-driven development. I will come to the details of that later, but this in order to build the code and to make it such that this code is understandable to the whole team. Pair programming has been also kind of characterized or saying that if extreme programming is all good practices taken to the extreme, so if you wish, pair programming is code review taken to the extreme, because you're always working with someone. And the way it works is that the pair who is working has a shared responsibility of the result. And this means that there is also responsibility in actually working together. This is not, let's say, if you, it is, in that sense, it forces you to communicate, to talk to others. But this actually brings to a very important aspect of pair programming is, or of actually human way of thinking or understanding. Coding is about solving complex problems, like understanding how to solve complex business requirements, whatever they are in your case. And then if you are working alone on your problem, wherever probably most of you work alone, then what you have is you have to figure out everything in your head, and then you write it down. There is no point in that process that you put whatever you think into words, that you have to verbalize whatever your ideas are about the solution. But this is actually a very important and powerful thing. If you have to explain your ideas or what it is, then it forces you to structure your thoughts differently and to kind of understand the problem much better. And through that, the pair, when working on the thing, gains much better understanding of what needs to be built. It is, I have said that it is quite easy and often happens that one person misunderstands the problem or misses some of the important points of it. But once 2 people are starting to building it and discussing it, it is very rare that they miss the same thing. It might be that they both miss something, but together they complete themselves, and the result is that they can actually, the end result in code solves the problem much better. And if the and it's always the discussion is that whether you are kind of wasting resources, that you put two people to build stuff when one might be enough, and it's also. But the reality is that the quality of the code, and not just the code quality, but the quality of the solution or the stuff that gets built is of higher quality because it is better thought through. And because it just exactly because the persons building it have had the need to talk through the solution as to how to solve the problem, and this is a very powerful concept which improves it. There is another side to it. It also forces you to kind of communicate, and this is something that developers sometimes are not, at least initially, very fond of. But we were just talking today with Andrei about this, and once you get used to it, this kind of it's also called like a safety net, is that the other person is there to help you. You're both basically helping each other out in getting the best solution. And when we had the COVID, and then there was a period where we basically sent everyone home, and then we worked from home. And although there were solutions in order to do remote pairing, and these have improved over the time, it is still hard. And whenever there is distance between people, communication goes down. And once communication goes down, then code quality goes down, and it means that also you are alone in making those decisions. So as coders, we every day and every moment making decisions about how to solve this and that, once you have learned that you can always have a discussion about things and have a, let's say, a much more weighted decision, then when you happen to be alone, it's much harder to make this decision. Even I myself, so the project I'm working on right now, my pair mate is a girl who is relatively junior. I'm a relatively senior developer, and even though, and right now she's on vacation for a few days, so today I was working alone, so it's, I mean, that's the way it is. Sometimes you still end up working alone. It's not that when she goes to vacation, then I have to go as well. But for me, it was much harder to concentrate on the work, to keep going, and to have the focus, because it is like a completely different way of working. And although you might argue that me being a senior, it should be easy to go, it's still much harder to make all those decisions myself, and without having someone to kind of talk through. It means that you also have to be ready to do it. This is something that there have been a few persons along the road. So Codeborn is now 13 years old, and I think I can remember 2 or 3 persons who have quit Codeborn because they have said that pair programming is not for them. And we are always, when hiring people, we are pretty frank upfront that this is what we are doing, this is our way. If you feel that you are not willing to do that, basically, then we don't, like, this doesn't work if you kind of force it. So let's see if I can open the door, sorry. So, sorry about that. So the point is that this communication, daily communication, and when we're actually hiring people, what we're offering now is to do like a trial day, which is basically they sit side by side with someone from our side, and do the same thing for, let's say, half a day or a day that we do regularly in office. And this gives a very good understanding of what it is. And now, having been through those, and also through times when someone joins, new joins CodeBorn, and working with them, I know that during the first week or two, once you are through your day, you feel very, very tired. So this different way of working is initially feels very hard, but for some, I don't have the very clear explanation, but people quickly get used to it, and it becomes very natural. So the other actually becomes tiring, so that you don't have a pair mate. Regarding also what pair programming does is, since this is like not a personal workstation but a team workstation, then what you don't have here is like messaging popping up regarding your friends, or you don't have Facebook open with your account, or whatever, TikTok and stuff like that. And it's and this is actually also important regarding productivity, is that although we don't have it, everyone has their phone. And I noticed myself today that when I was working alone, my hand went and opened the phone just as because I wasn't focused so much on this, because if you're working with a pair, then it's much harder to kind of say, oh, I won't listen to you, I will switch to my phone or something. So it keeps you more disciplined. And this being disciplined on the coding task is on one hand good for the work, but it's also tiring. So the other side of that is what we do is we have strict that we have 8-hour work days. This is not, we don't have that people have to work overtime. We also have good breaks. We have all the relatively nice office here, everything here, the football table up and stuff that people can also take breaks, so that they relax from this. But this is something that where you agree with the pair, okay, let's take a quick break, you relax your brain, and then you go in again. But then when you are working, you are focused, and this is a very valuable thing in terms of getting things done, and yeah, having good results. So yeah, and now the actual writing of the code. So test-driven development. How many of you are actively doing test-driven development? Yeah, I see a few hands from CodeBorn and a few others. Very good, and you, very good, excellent, but very few still. So test-driven development. I will not do a full lecture on test-driven development. There are probably very good resources out there, and it is definitely there, and it is hard. It is a discipline. And I'm pretty sure that everyone of CodeBorn doesn't do it 100% of the time every day. Yeah. So that's not the case, but that's still the, let's say, default thing. And you're not doing the default every day, and there are situations where it's okay to skip, but let's say the default in working, it is still about the test-driven development, writing the test to show that something is missing. What test-driven development mostly is about, if you are building something, then the idea is to break the idea down into so small pieces that you can write a small test that shows that something is missing in order to achieve that thing. And then once you add the code that shows that now you have that code to satisfy that, then add the next test which shows that still something is missing, and next, and going back and forth is with the stuff. The hard part in that, and the thing that mostly requires learning, is the skill to break down your task in such a way that you will start with small tests and slowly adding the functionality. Because if you are a developer with maybe a few years of experience or with some experience, you will, once you read something or you hear of the functionality that you need to build, you will build some mental idea how to code that, and the initial like instinct is to jump in and write everything as like in one go. Most likely, and I guarantee most of you will either write too much of code and then also miss some parts of it. So the code will not be enough. It will contain something extra that is not needed, and it will probably contain something that is, it will not contain something that is required. The way, if you learn to do it test-driven way, the first thing is write the simplest test, right? I was building something today, and the first test, so this was about getting some results from database and then going through them one by one and then leaving out some of them, basically filtering, and then doing something with the rest of them. And then the simplest test is what if the list is, the result is empty, there is nothing to do. But what you can still do is verify that you call the right function from the database, that the basically that the call was with correct parameters or something. The next thing is, if you have only one thing in the list that needs to be processed, then you can verify that. That is the next test, but you can always go like back and forth. And then the next test is, if you have one thing that you need to filter out, then you test that the result will be empty. The first instinct with everyone would be to write the test that tests, one test that tests all of those cases at once. While it is very tempting to do that, why not to do that is to, when later on something breaks, and then one of those tests will break, but the others will work. And then the name of that test will explain you a little bit, at least, what did you break. Because if you have one test that tests everything and that breaks, it doesn't help you much. You know that you have some functionality that is broken, but you don't know what is broken. But if you have those small tests, then and half of them work and half of them don't work, then it's already closer to the solution, is that, or the answer is, what did you break and what still works. So these kind of small things, moving in those small steps is very important. So I thought I will quickly show some code here. I'm using the project that I'm working on right now. I will not go into the details of like the functionality of the project, but I will just show the code a little bit, and mostly about on the test side. So what was it? Presentation mode. A little bit larger. Yeah, so this project has been going on since, I think, the May or something when we started. And it was the first time today, when preparing for today's talk, I ran the tests with coverage measuring turned on. This is the first time I did this. We hadn't basically bothered about the numbers. We were confident that we had good tests. So this is the regarding the backend. This is Java, but it really shouldn't matter in that sense. So this is what I found. So okay, and I will also run. Yeah, I will run. So this is running through the whole test suite right now. So let's see how fast it goes. I will go into the details a little bit later. But so you see about, yeah, we are getting close to 1,000 test cases here. So just if you're using Java and IntelliJ IDE, you might have noticed that initially there was something, some different number here. Since we're using parameterized tests, then IntelliJ has a bug in counting them. So in reality, at least, that's the number. And you see, so yeah, okay, this 5 seconds. Yeah, I think it's it was a little bit more, but still relatively fast test suite. And this means our if anyone knows how to get a quick line count statistics from IntelliJ, then I can show that as well. But yeah, there's cheers. Yeah. But anyway, there is quite a lot of code, and this also why it took some time. It was, let's say, for my eyes, it was somewhat slow. The slowness comes from the fact that it is also executing database tests, which means that it is actually talking to a real Postgres instance, also running in this machine. It is starting it. Okay, in this case, the Postgres is already running, but it's creating all the data, all the tables, everything whenever I run it. So if I run it again, it will start. So there is probably, yeah, you can see the migrations are going through here. So it's creating all the data structures, and yeah, now it's executing all the tests. And yeah, we have about, so depending on how you count, but at least 70% of line coverage. I am pretty happy with that. So there are a few classes which are, let's say, such temporary stuff where we have almost 0% coverage, and so the rest of the stuff is close to 100%. What I thought when I was like thinking about how to or what to emphasize about test-driven development, because once you start writing tests, then like what is the, let's say, words of wisdom, or what I can say from my practice. And then what I realized is that for newcomers to test-driven development or to development at all, or in these projects, what I've seen is that if we have the patterns of how to write the test in place, then it's much easier to write the next test. So so this is a web application where this is the backend. It's a REST backend, so we have controllers there. This is a Spring thing, so the Spring terminology. So we have controllers, we have services which do the business logic, and then we have repositories which deal with communicating with the database. So, and then we have a few utility classes which are just plain old Java classes, which is just easy to test. But the point is, for each of those different types of classes, we have, although not documented, we have our own mental model of how to test those, how to prepare. I think the hardest are the ones, let's say initially to start with, the ones that talk to actually database. But once you get over the initial burden, then you have these patterns in place. Okay, this was done this way, I can do it here as well. So continue on that, and it's quite easy. So let's see with some of the repository tests. Let's see, maybe this one. So, okay, this is okay, let's jump to the tests. They're not so much in the code. So we have some base classes for the tests. I will not go into all the details, but the point is the tests are relatively small about writing how to write, and these all go to database and actually execute SQL queries, load data, write data to the database, stuff like that. And we have the basically the infrastructure is supporting that. The important part here is that when we have new people joining the project or stuff like that, it is for them, it is really easy to jump in and start doing that. If you are the most senior in the project, then it's up to you to build that, and then probably if you're starting with that, then at least understand that it takes some time to put this. But having those common patterns in ways of doing it is tremendous help in that. Another trick for tests, what I thought I will show is about yeah, which one was it? No. Yep. This is about situations where you have to validate input data, and you have different validation rules, and this is for here. I will quickly jump to the code. So we have different validations here. Again, ignore the details. A tip or a pattern that I wanted to show is that all the different tests that test the invalid cases are really short ones. And the trick here is that I have one method which prepares a valid, in this case a person, but it changes one part or the other. So all of those start with a valid person, but then adjust some field of it and then assert that the result is some validation error. So the important part here is that it is really easy in this, even if there is a new validation rule that pops up or something like that, then it is really easy for the next person to go in there. And even though there are probably, I know how many, let's see how many tests there are in here. So yeah, 23 different cases are tested. It's not such a long test file, and the parts are relatively easy to read. So there are some of those parameterized tests and stuff like that. But the important trick which I wanted to kind of show is that for those, you can always have this preparation code that starts with something and then only change one thing and validate that it fails. So this is the yeah, one test here is some like the happy path, which then validates that everything goes through correctly. But then all the validation errors are quite easily tested. One more thing, let's see some of the controllers here. So the controllers are usually for us relatively simple. And this one actually is covered by tests, I can see here. I was looking at some other ones. Actually, I thought I will find something which is not covered. So we have those one-liner controller methods, which sometimes are not tested. I will call that laziness from our part. Yeah, I'm standing here saying that the important part is what I have understood is that it is all clear and like there isn't nothing like special to test in this case. It is just getting some input parameter, passing it on, and that's it. Even if it would be 2 parameters, something, there isn't anything. But the hard part is that most likely many of those will need to change in the future. And the trick is that if you have a test in that case, then the next guy who has maybe to add an if here something, if the test exists, then it's easy to jump into the test and add one more test case, because at least the preparatory work is done. But if the test doesn't exist, then the step to getting into a running test is not much higher, but still somewhat higher. And that actually makes a huge difference in this kind of mental jump into, will you have the next test or will you have the complexity increasing, but still people say, I don't write the test because there wasn't a test previously. So these kind of small things, if you understand those and kind of work on top of those, makes this easier. And yeah, the test-driven part is about getting the better results. So yeah, what I wrote is almost no technical depth here, is that there is always some technical depth. It is about being either confident that you can handle that once you get to that point, or if you don't get to that point, if you think that there is too many places, then there is too much. I mean, it's okay to leave some things for later, but if you leave it all the time, you're basically, then you will soon be in a pile of whatever you want to call it. But the point is that you have to kind of make this trade-off in getting things done quicker, maybe getting some of those like controllers done quickly, or next time when you go in there, just add one test. It's relatively easy when you have 2 more minutes to spare. It usually, once you have those patterns in your head, it's really easy. For you, probably the test here, if you haven't done it, then there is a lot of concepts here which are not maybe familiar. Some of you might, but like things like mocking and maybe some other ideas here and verifying stuff. But once you get used to those, then those building blocks are the same. All the tests are the same. Very important part is when you write tests, if statements do not belong to tests. For loops usually also don't, or this kind of conditional and fancy stuff. Most of the tests are about just linear stuff, just going through, preparing things, executing something, and then verifying the results in what way they. So again, maybe all the tests should be, you should be able to recognize 3 parts. So in English they have called it like AAA, AAA. First is arrange, I think was this. Then it was act, and then it was assert. I think these were the right words. The idea is you prepare the data that needs to be done, that needs to be like prepared for this test to execute. Then you act, like you basically, you do the stuff that you're actually testing. And then in the end, you assert that the result is what you expected. And even so what we try to do is, so if you look at this code that is without the changes, the code is also, these new lines here are not in random places. These are, and for me, if I jump into any, probably, let's take any of the tests, here is, okay, here the trick is that this assert is a helper method which does the same that it does the first the act and then the verifications or the asserts here. And if we look at some other tests, again, there is some preparatory code, then whatever we test, and then the verifications here. So it's always about whenever, and some of this code is written by me, some of this code is written by some other teammates, but the point is when we jump into that, we quickly understand what is going on and what the structure is. Again, this is about patterns. Doing things using those patterns makes it easy to follow and easy to add new stuff. So that's the important part. So I'm looking at the watch here. We are getting closer to 8, where we hopefully get pizza. So I will actually, if you have questions, let's take them now, and I will maybe then. There was initially about design and design documents. So the way it probably. I think if what you had in mind is like how do we communicate design, or how do we like ensure that it's the same, or what the idea was initially, or what did you mean?
In a big company, you need to communicate, explain what you want to achieve, what you want to build, and if it's a technical solution like writing a new service or integrating multiple services, you want to first design what you want to build and then show it. So how do you do that? Okay.
Probably 2 parts to the answer. We don't have separate documents as that such. The code is probably the example of that, but the way it goes is that once a project starts, then whoever are the first people on the project, they initially build those concepts, put it into the code, and then when new people join the project, this is actually something that I forgot about pair programming is whenever a new pair joins, then important part of it is knowledge transfer. So we never put it so that we just take 2 new people and put it to a project and start working on it, although this is already a long ongoing project. Usually a person joins and then they join someone who has been working on that project, and then the discussion that goes on in that pair is about this knowledge transfer. So this has been a very important part of how to share understanding of a project is through this discussion and stuff like that. This is where we communicate the how we do things and then the way we solve different issues usually. So yeah.
I think the reason for that question was that like, how do you communicate the change in a larger project within a group that is larger than like 6 pairs, for example? But it sounds like you don't do projects where there are more than 6 pairs. Is the reason for that you haven't managed to sell a project that is large enough? Or is there a like, natural limit to how useful this practice is in a group?
If you wish to put it this way, yes, we haven't managed to sell a project which is larger, which requires more than 6 pairs. I would challenge that I cannot imagine of the project that would need more people, because the more people there are, the more basically time you lose to communication and stuff like that. So we have done pretty significant things with 2 or let's say 4 or 6 people. And the stuff that we are doing right now with, I think, 4 or 5 pairs is a multi-year project for a company outside of Estonia that I have in mind. And initially, they also thought that they probably need 100 developers or something. It still usually boils down to that requirements are not clear enough so that we couldn't even put more people up there, or they couldn't, let's say, verify or be ready to accept that much of work. So in that sense, there probably is somewhere out there such a project. I just haven't seen it, and you might consider that as my limitation. What I do on the agree on that sometimes there are larger systems which just have different people working on it at different times, so there still might be more people involved. What we also do is, in some cases, it is always about as much as possible direct communication with the people. So sometimes we have customers, developers working side by side with us. So we are doing this pair programming with customers people. Usually the way it goes is that when a project is its initial phase, when we are building stuff quickly and then the project is quickly growing, then it is about more people, and then the project goes into, let's say, maintenance phase when the system is more or less ready, and then new features get still added, but it's much slower pace. And usually in those situations our customers want to have their own people who can do it on a much let's say slower pace. They don't have such haste, but they want to have people who know the system. And then through this pair programming and coding together, working together, we actually transfer the knowledge to them and they can continue in maintaining that. But the other part is test-driven development. So I might argue these same tests, these are part of this is not about design documentation, but about what the functionality, what the system actually does. So this is it. There are a few, let's say, examples where we have done some, let's say, diagrams or sketches or stuff like that to illustrate some more broader concepts in some situations, either to the customers or to our own teams, but these are very rare. So most of the time we don't see much value in that. So it's more about going in there, actually working there and doing the work, and then you don't need much else. It's about communicating. So yeah, when you're working alone, then you want to look at some document to understand it. But if you're working with someone who has been there, then you work together. And then, yeah, one of the things which I didn't have time was this also the open workspace. If there is more than one pair, then they also, not like on a minute by minute basis, but they still talk to each other. So if there is like something that one pair doesn't know, they quickly turn to the other pair and ask about concept or things like that. So there is active communication in that sense as well.
Isn't it too loud to work in this?
Very good point. What I have, again, through experience understood is if you're working with a pair, the way human mind works is magical in a sense that if you're working with a pair, you quickly adapt to that person's talk, because you're working together, you have like a conversation, you quickly adapt to that and you kind of ignore everything else. Once you're alone, and at that same table, everything else is the same, but you just don't have a pair, and then you have to work. Then you start hearing everything that is going on in the room, and then you get distracted. So we have we have designers who work alone, so they have their headphones on. We have some people who, again, like sometimes work alone because their pair is on vacation or something like that. These people also sometimes put on their headphones, or they are doing, we have what we call R&D days where they learn something or stuff like that. So in that case also they use headphones or something like that. It is when I realized what is or how this or that this is happening is then I didn't understand how it works initially, because yes, this how can you block out the noise? You cannot if you're working alone. But if you have someone to talk to, then it works out automatically. You don't think about that. It just, that's the way human mind works. And this is, yeah, a trick.
Do you have pairs which are married to each other?
There is one pair who, I don't know if they are married, and they don't, they work in a team. So if there is more than one pair in one project, we encourage people to switch as much as possible, so that not between projects, that doesn't work so easily, but within that project, the more, I mean, ideally it would happen that each day you switch this. That happens very rarely, but at least once a week, just switching the pairs, this is very healthy, and we encourage it, and it helps also in not getting into the comfort zone too much in different ways. So it's not possible in case of two people, or just two people in a project, but if there are more, then yes, this is a very important part of it.
Someone mentioned about documentation. How do you document and communicate architectural decisions and align on that between the pairs or in the team? Do you just use a README in the repository? Or?
We sometimes have READMEs and some sketches, but most of the time this is again through this, just through code, through this everyday communication. This is the very different thing is that we talk all the time. Yeah.
The first, I will start with what this guy said about like if you have a big project, I mean like several microservices that should talk to each other and so on. Then first you can sketch the architecture and delegate it to different teams, because you already have designs like database and so on. And I mean that work that is dependent on each other and can be done in parallel. And in that sense, yeah, you may need more people. Also about design documents, I understand that when you're developing a project, when you're involved, you keep mostly everything in mind. So you don't need design documents and so on, because you just know how it works. But if you will return to this after, let's say, 6 months, you will either need to follow the code to understand how it works, or it's better just to look on the diagram and you already briefly know which module is capable of what.
Unless you spend extreme amounts of money on people basically working, then any kind of documentation that gets done quickly gets out of date. So even though if you read the documentation, or if you had the documentation, then I still wouldn't believe that, and I would still go into code and check if that is the correct thing. So that is the, maybe quickly go, yeah. But regarding architecture, so this is about simple design and stuff. This also goes about architecture, and I probably that was also in the previous talk as well, and a little bit repeating. But microservices is one very hot topic, and probably I should kind of see if let's say a few minutes more, then we'll jump into the pizza. But I will quickly try to answer. The idea is that any kind of architecture, we try to do it in a way that there is enough of it to settle the problem, but that will, in most cases, get us into the situation where we don't have things like microservices, service-oriented architectures, or what are the older acronyms or stuff like that, or Kafkas and stuff like that. And these things are related to each other. When you go into these, let's say, fancier architectures, then you will also see that you will need some documentation and people who go out and preach this, and you need like architecture with like who don't code and just go around and tell people how to do things even though they don't know themselves. That you will quickly get to that, and we will, the way we work is we try to avoid all that. And we have been able to do that for many, many years in many projects, and even though the complexity grows, we'll try to keep that under control, and there are some projects where there are, let's say, more than one service. I wouldn't call them microservices, but an important aspect is when you're thinking about either microservices or different parts of the system or stuff like that, when we are building a functionality, and this when I mean some very small piece of functionality, then we make sure that that functionality works, period. And it works when the UI talks to the whatever the lowest layer in being your just relational database, which is most cases for us, or some other storage or whatever. All those things in between also work. So even if there is some reason for having multiple services somewhere on the road there, basically, we still, that same team is responsible for making sure that it all works. And if they need to switch between different projects, services, whatever, they still, it's the same people who need to take care of that.
Does it mean that you delegate DevOps problem to the customer? I don't know. I think we want to avoid that also, that the software works itself. It doesn't just need DevOps. It's not all, I mean, you need someone to understand the system. It's more about having if it's more complex system, then anyway, things evolve over time and you need someone who understands it. And if you call that DevOps or, I don't know, but it's the team who has to make sure that the system works. And that, in most cases, it also involves like DevOps, which is sometimes, I think, considered DevOps work. So, yeah, go. What?
Questions. So, about tests, there's, I understand unit tests, of course, then some engine tests, but you said that they should be small, and I mean, if you're testing only like talking to the database and some utilities and so on, then how do you actually test the business logic? Because this part should be tested as well, right?
Let's say it varies from project to project. Some project has more these kind of end-to-end tests, which actually execute the UI and verify that it goes through. For instance, this project that I was showing didn't have it. It also has a UI layer written in Svelte, which is has its own unit tests probably. They are a little bit more than unit tests. They are using the Svelte component, and it is much less coverage than is in the backend side. Since we have most of the logic in the backend, then we are pretty confident in that. So the way I think it's called the testing pyramid, that you have the unit tests as the widest based, and then the higher you go, the thinner it goes. We are doing that, and in some cases it's like going very thin very quickly. So the unit tests are the most important and the heaviest part. Sorry, let's just one more question, and then let's take the break and we can continue it over the pizza. But yeah, sorry.
Question, you told that you don't sell, cannot maybe, or you didn't sell big projects, but how do you imagine if, for example, Volt or TransferWise decides, big company with thousands of people decides to become pair programming company, how will it look like? Will some roles disappear? Will the amount of people, workers be reduced? How do you imagine in big company pair programming?
It is never top down. So if the someone, whoever is the head of those companies, or the tech head or something, said, let's do pair programming tomorrow, then it won't work. It's something that, for us, this is something that we have been from the start. When we were doing this before Codeborn in Swedbank, this is something that we started to do within our team. Our managers supported that, but this is something that was internal to our team. We learned to do it. This is what made us more effective. And this is the, like, let's say this from
down to up is the way to go there. I don't believe any organization could like just switch from doing it. It can grow internally or organically.
Not the structure in big company, because like there cannot be open space for 1,000 people.
Yeah, but I mean, you don't need it. I mean, the teams who need to work together is the part. But sorry, I don't want to delay it so much. So let's finish it for now. Let's have pizza over there and we can continue there. Thanks.